In today's video, we're going to walk through how you can create a cost-effective approach to deploying multiple web applications directly from GitHub to a single Linux server. This method empowers you to deploy your small projects and low-traffic applications to extremely cost-effective hosting while retaining all the advantages of GitHub services by using fundamental tooling like Docker, Docker Compose, and SSH. As software developers, we often encounter the challenge of taking our carefully crafted applications and making them accessible to the world. And while cloud-native solutions like Kubernetes can be very powerful, they can become extremely overwhelming, especially for small projects that don't need horizontal scaling. Moreover, cloud solutions that try to make this process simpler can also lead to vendor lock-in and highly complex billing structures. In this tutorial, we'll present you with an alternative deployment approach that streamlines the process and avoids some of the challenges associated with traditional cloud-native methods when it comes to hosting, but still leveraging the amazing tools that are likely already at your disposal thanks to GitHub. By leveraging the infrastructure provided by GitHub, you'll have great tooling to orchestrate your deployments while retaining control and flexibility by using fundamental tools like Docker, Docker Compose, and SSH. We'll guide you through using the necessary tools like Docker Compose and SSH, as well as Nginx Reverse Proxy and LetsEncrypt for routing, TLS, and certificate management. This combination of tools will empower you to manage your server effectively without sacrificing some of that simplicity and flexibility. By the end of this video, you'll have a solid understanding of how to set up this deployment pattern and deploy your web applications from GitHub. Whether you're a seasoned developer or just starting your coding journey, this tutorial will help you get started with everything you need. Alright, so now that we have a clear understanding of what we'll be covering, let's dive into the core components and get ready to deploy our applications. The key components involved in this deployment process are GitHub, Docker Compose, Secure Shell or SSH, and a Linux server that is running Docker with an Nginx Reverse Proxy and a LetsEncrypt companion container to create a reliable and efficient deployment pipeline and cost-efficient flexible hosting. The first of these key components we'll be looking at is GitHub itself. As a platform, GitHub provides an array of features that support our deployment goals. We'll specifically be leveraging GitHub Actions, GitHub Actions Secrets, GitHub Container Registry or GHCR, and of course the GitHub repository itself. GitHub Actions serve as the backbone to our deployment pipeline. These automated workflows handle the process of continuous integration or CI for our application. They check out code, set up the necessary environment, build, test, and deploy our application. We'll be walking through this workflow step by step shortly, but if you want to grab the workflow YAML file yourself, you'll find a link in the description. Next, to ensure the security of our sensitive information, we'll be using GitHub Actions Secrets. These secrets are encrypted in our environment variables stored in GitHub. They allow us to securely store and use sensitive information like login credentials, tokens, or keys throughout the deployment process in our GitHub Action workflow. The GitHub Container Registry, or GHCR, is where we'll be storing our Docker images which are built in our GitHub Action workflow. GitHub Actions will automatically build and push Docker images to GHCR as a part of this workflow, and this provides a secure and versioned storage location for our images, which can be pulled by our Linux server during deployment. And of course, we have our GitHub repository, which will serve as the central location for our application's codebase. This will also include where we'll configure our GitHub Actions and store our Docker Compose files. Next, we'll look at Docker-related components, like Docker Compose, which is a fantastic tool that simplifies the management of multi-container Docker applications. It allows us to define our application's environment in a single YAML file. With Docker Compose, we can ensure consistent setups across different environments. Docker Compose will be installed on our target Linux server, and it will be used to pull Docker images and run our application. By using Docker Compose, we can easily manage our application's dependencies and ensure a smooth deployment process. The next component we'll be looking at is SSH. SSH is a protocol used for securely connecting to a remote server. In our deployment process, we'll use SSH for copying our Docker Compose files and executing commands remotely on the target Linux server that we're deploying to. Which leads us to the Linux server setup itself. The good thing about this approach is that provided that Docker has been installed, Docker Compose tooling is available, and your server is accessible via SSH, you can choose whichever Linux distribution is best suited to your needs. It also means you have a wide variety of providers to choose from when it comes to hosting that server. You could use the well-known providers such as Amazon Web Services, Google Cloud Platform, or Microsoft Azure. But since we just need a single Linux server or virtual machine, there are a lot more cost-effective providers out there like DigitalOcean or Hetzner Cloud. Today I'll be using Hetzner Cloud with an Ubuntu 22.04 virtual machine for this tutorial, but you can adapt this process to suit your preferred method of hosting with very minimal changes. Once you have access to your server, the first step is to update it and install Docker and Docker Compose. We can follow the official guide on the installation of Docker, which is a very small script we can then copy and paste into our terminal. By default, the latest version of Docker comes with Docker Compose. However, if you need to install Docker Compose separately, I'll leave a link to the official guide so you can follow along for this video. After the installation, you can confirm that Docker and Docker Compose have been correctly installed by running docker -- version and docker space compose. If those commands return the Docker version and the Docker Compose options respectively, we have now installed Docker and Docker Compose successfully, and we can move on to the next step, which is running an Nginx Reverse Proxy, which will handle our HTTP routing from our server address to a specific container which is listening for a specific domain that we've configured with our web applications. This means our server can run multiple web applications together on the one server, and the Nginx Reverse Proxy will handle routing the traffic to the correct container. And when this is combined with a LetsEncrypt companion container, we have automatic secure connections to our web applications using TLS, which is automatically handled, and we don't have to worry about it because this LetsEncrypt companion container will automatically set up our TLS certificates and manage the renewing of them as time goes on. To get both of these containers set up and running, you'll just need a Docker Compose file which has everything you need, and I'll leave a link in the description for this as well. The only thing you'll need to change is a default email on the LetsEncrypt service in the Docker Compose file. This email will be used by LetsEncrypt to notify you of any important notices you'll need to know about your domains and the related certificates. Something worth pointing out is also that this Docker Compose file declares a specific network called Nginx. This network will also be used by your web applications in their own Docker Compose file as an external network. Your web applications will join this network with the Nginx Reverse Proxy, and the Nginx Reverse Proxy will automatically detect your web application and begin routing requests to it based on your web application's configuration. We can then copy the contents for this Docker Compose file and then paste it into a new file through our terminal. To do this, we can create a new folder for our Nginx Docker Compose file called Nginx, navigate into it with cd space Nginx, and then type in vi space docker-compose.yaml. This will open a new vi editor. By pressing the I key, we'll change it to insert mode, and we can right-click to paste the contents of our clipboard into the file. We can then hit escape to exit the insert mode and input in the command :x and hit enter. This will save the file to the Nginx folder, and then we can run this Docker Compose file using the command docker compose up -d. This will run the services registered in our Nginx Docker Compose file and run them in the background or in detached mode. And now that our HTTP server and our LetsEncrypt for certificate management are all set up, we have one last step to enable deployments from GitHub Actions, and that relates to how GitHub Actions is going to securely communicate with our Linux server during deployments. And it does this via the same mechanism used to connect a terminal to install Docker and Nginx via SSH. To keep our own access separate from deployments, we are going to generate a new SSH key pair that is a private and public key, and tell our Linux server to enable access by updating a file called authorized_keys. This is how you control which keys can access your server for which user. For simplicity, we are going to use the same user. In this case, that is a root user. But if you have stricter security requirements, you have complete flexibility when it comes to how you configure your Linux server. To generate the new SSH keys, we're going to use a command ssh-keygen -t using the option ECDSA, and then -C, and you provide your email. By default, this will generate two files, the id_ECDSA file and the id_ECDSA.pub. The file ending in .pub contains our public key, which can be safely shared. The .pub file contents will be added to the Linux server in a new line in the authorized_keys file in the .ssh folder in the user directory, enabling the SSH access for that user when using the file without the .pub extension, i.e. the private key. The file name with just id_ECDSA contains our private key, and this is going to go into our GitHub Actions secret and will be used by our GitHub Action workflow to copy files and run commands remotely on our Linux server. This private key must be kept secure, and it's best not to use it for any other purpose other than for your GitHub Action deployments. Okay, so after all that, we now have a Linux server ready to be used for deployments for multiple Docker applications. And while this might be more work than using a more turnkey solution from a cloud provider, this approach is completely portable, and it uses tools that are highly reusable and valuable to know as a software developer. You can certainly get by without knowing them, but since these tools are so ubiquitous in our industry, they are likely to come in handy throughout your career. Next, we could focus on deploying our web application using GitHub. The first step in our deployment process is that you're using GitHub as the central location to store your application's codebase. It provides a host of features that supports our deployment goals, and here are some of the key features that we'll be leveraging for this deployment process. First, we have GitHub Actions. These are automated workflows like we've discussed, and they handle the process of continuous integration for our application. And that is, every time we check in a new piece of code or update an existing file, they perform tasks such as checking out our code, setting up a necessary environment, and then build and testing the application and creating the release that will deploy to our Linux server. And it's the GitHub Actions that leverage GitHub's other features, such as GitHub Actions Secrets. This is where you can safely store sensitive pieces of information like your keys, passwords, and other credentials that you can't safely store in your codebase, but your application or continuous integration environment like GitHub Actions still needs to deploy your application. GitHub Actions secrets are encrypted and allow us to store such information securely. This is essential for building and pushing Docker images, for example, during our deployment process, and remotely accessing our Linux server to deploy our application. Next is the GitHub Container Registry, or GHCR. And this is where our Docker images will be stored and versioned. GitHub Actions will build and push our Docker images to GHCR, and our Linux server will pull them down during deployment with a specific key provided by the GitHub action. It provides a seamless integration with GitHub Actions, and it makes it easier to manage your images for your application. So now that we understand the key features of GitHub that we'll be leveraging, let's see how they work together in our deployment pipeline. Workflows are configured to listen for specific events, and in this case for our release process, it's listening for the build action workflow to finish, a new release being created, or the workflow being manually triggered using the GitHub Actions UI. When one of these events occurs, it has two jobs to complete. One is to build and push our Docker image to GHCR, and the other is to deploy via SSH. Each GitHub action job is made up of individual steps. Steps can be as simple as executing a shell command or as complex as invoking a pre-packaged action, which is a reusable unit of code from either your repository or shared by the GitHub community. Each step in a workflow is a place where you can halt the workflow with a failure if the step doesn't succeed, and it allows for granular control of your CI process. In this case, our push to registry job is checking out our code, constructing what tag should be used based on the type of event received, and then assigning some variables for use to then log into GitHub Container Registry and build and push the Docker image of your application to GHCR. Once the push to the GitHub Container Registry is successful, the process proceeds to the deploy via SSH step. This step involves a whole new set of actions because the environment that the CI runs in has been cleared, so we need to check out the code again and then continue with the process. Next, it creates a .env file or environment file by extracting secrets from the GitHub Actions secrets and storing them in the file. This .environment file is then copied along with a Docker Compose YAML file and a Docker Compose.prod.yaml file. This is done via a shell copy targeting our Linux server. It does this by utilizing our generated private key that is stored in our GitHub Actions secrets. The process then continues by preparing some environment variables and running a remote database migration via an SSH action. This remote database migration step is actually running a service that's declared in the Docker Compose YAML file. So if you need a similar step, you just customize the app-migration service in your Docker Compose file, and this release workflow will work as is. The next step is executing several Docker commands remotely on the target Linux server, such as docker pull to pull new versions of the images that are declared for use in your docker compose.prod YAML file, and then calls docker up -d, which then runs the new version of your application that was built and pushed to the GitHub Container Registry in the previous step, and then the process has completed. During our deployment process, the GitHub action workflow plays the central role, but additionally, we need to address the Docker Compose YAML files, which define our application's environment for when it runs on our target Linux server once it's deployed. The release workflow referenced two Docker Compose YAML files, one that can be used standalone locally to run our application, and the other is designed to merge with this Docker Compose YAML file specifically for the target Linux server's production environment. This is why we've split them to be called docker compose.yaml and docker compose.prod.yaml. The last of these three files that were copied to our target Linux server was the .env or environment file. This file was generated by the release workflow and then copied along with the Docker Compose YAML files. This specifies some environment variables that are used in our Docker Compose files and that pull in values from the .env file. This can be used as an easy way to switch important values. In our case, we're using it for virtual_host, the LetsEncrypt_host, and the LetsEncrypt_email variables, which are used by the Nginx Reverse Proxy and the LetsEncrypt companion containers. The virtual host informs the Nginx Reverse Proxy which requests to forward to our application's container, and the LetsEncrypt email informs the LetsEncrypt certificate manager which email should be associated for the renewing of the certificates. Okay, so now we have everything we need committed in our GitHub repository. That is, we have our Docker file which defines our application. We have our Docker Compose YAML file, our Docker Compose prod.yaml file, and the GitHub workflow itself, in this case called release.yaml file. This release.yaml file expects 4 specific GitHub Actions secrets to be configured. That is a deploy_host, which should be a DNS record that points to the IP address of your target Linux server. So for example, you could have app.example.com, where that subdomain is configured as an A record pointing to the IP address of your target Linux server. Next, we have the deploy_username secret. This should store the Linux username that is used to log in to the Linux server to perform those remote actions. This will work along with the deploy_key secret. This is where you'll store your generated private key to perform those deployment actions. And lastly, we have the LetsEncrypt_email value. Again, this will be used by LetsEncrypt to notify you of any important information regarding your generated certificates. Out of these 4 GitHub Actions secrets, there's really just deploy host, which is application specific. That is, it's the domain or subdomain which represents how you can access your web application and how the release process connects to the backend Linux server to process the deployment. All the other 3, which is deploy username, deploy key, and the LetsEncrypt email, could be used as GitHub organization secrets, and that means they can be reused across multiple GitHub repositories in the same organization. This is particularly handy if you want to manage multiple applications deploying to the one Linux server for, say, a lower environment, or for prototyping applications, or a series of low traffic systems that only need the one app server that can be shared. And since GitHub repositories are unique within a single GitHub organization, it means when these applications are deployed to the file system on the Linux server, they're stored in unique folders so they don't interfere with each other. This means you could template the Docker Compose, the Docker Compose prod YAML file, and the release.yaml GitHub action workflow within an application template to quickly get this process up and running for a new application. And we have an example of this for .NET applications in the ServerStack application templates that are available via the ServerStack.NET X tool. And this same pattern could be used for any language or framework combination, so that if you have a specific stack that you use in your organization or for your own personal projects, you can automate most of the work required when starting a new application or integrating that application into the same deployment pipeline. And once multiple applications have been deployed to your Linux server, you can use a great tool called LazyDocker to monitor all those applications. This works with your existing terminal access to your Linux server, so you can run this even as a Docker container itself and visualize the memory usage and CPU usage of all your different containers for that server. So to summarize what we've done in this video is we have taken all the great tooling available to us by using GitHub for our repository and configured a repeatable deployment pipeline that can be used for any web application that we can Dockerize. This is then deployed to a Linux server via fundamental tools like SSH and Docker Compose. So while it's great to learn sophisticated tooling like Kubernetes to deploy applications in complex scenarios that require horizontal scaling, there are a lot of situations where an application will fit well within a cost-effective Linux virtual machine. And this is especially useful when you need a very cost-effective way to deploy lower environments for applications or a place for proof of concepts, and you don't need the level of redundancies that's sometimes required for more complex mission-critical applications. Well, that's it for this video, and I hope this has been useful for exploring the different options you have when deploying applications using fundamental tools like SSH, Docker, and Docker Compose. So while it might not be for everyone, I hope at least it will give you another option in your developer tool belt when weighing up your options for creating a deployment environment for your organization or for your personal projects. And as always, thanks for watching.